Hi, this is Angelo Black, the grumpy old IT guy. That's right, you heard me correctly, the grumpy old IT guy. And welcome to my grumpy podcast, Creating Tables. This is the third podcast in my beginning TSQL podcast series. Now, each podcast has a demo or two, or maybe even more, so just make sure you pay attention, kids. And by the way, there'll be two other series of podcasts which I hope you'll find useful and helpful. There'll be the intermediate TSQL series, which is coming late summer 2020, and then the advanced TSQL series coming in late fall of 2020. Now, after taking all three series, you'll be able to perform basic queries and development tasks associated with a TSQL developer. And just here's a little grumpy comment. Now, these podcasts only cover the basics, so please look to my fall 2020 Grumpy University for in-depth courses and modules on these topics. And I need to warn you, they'll be subscription-based, which means you gotta pay for them, but they'll be at a really, really low cost. So I hope you check them out. Okay, by now you're probably asking yourselves, who is this grumpy old IT guy anyway? Well, that would be me. I'm a published author and data architect with over 30 years of experience in BI, data architecture, data warehousing, and data modeling. And before that, I was an electrical engineer, believe it or not. Now, in the last 10 years, I've also participated in several large-scale master data and data quality initiatives. And to support these, I've achieved CIMP certification in master data and data quality. I have to admit to you that I love the Microsoft BI stack, and I've been using SQL Server for more years than I care to mention. Does anyone remember SQL Server 2000? Well, I go earlier than that, and I can just hear you guys moaning and groaning and saying, hey, this guy's really dating himself. Well, that's okay. Anyway, BI stands for Business Intelligence, in case you're not familiar with that acronym. And lastly, I hold a master's degree in computer science from New York Polytechnic University and bachelor's degree in electrical engineering from Pratt Institute, and way back when Pratt Institute had an engineering program. Now, both these schools are in good old Brooklyn, New York, USA, and I have to admit I had a great time, learned a lot, and met a lot of great people, and I did my little share of goofing off too, but those were the days. And oh yeah, here's a little grumpy comment. I'm now the founder and president of grumpyolditguy.com. So get ready, guys. Get ready to learn the grumpy way. Okay, so what are we going to cover in this podcast? It's a pretty simple podcast. We're just going to cover the basics to get you started with table creation and management. And specifically, we will look at how to create tables, load tables, and drop tables. And we'll do this in two ways, one with SSMS and the other way with TSQL code. Now remember, SSMS stands for SQL Server Management Studio, and I hope you took my prior podcasts on how to install SSMS and also how to navigate through SSMS. So this will be a rather quick and easy podcast, so let's get started. Okay, here we are with SSMS. All you need to do is just right-click on the Tables folder and select New. All right, and it's really simple. This is the first step. And then what's going to happen is you're going to get a design panel in SQL Server Management Studio. Now, this allows you to enter the names of columns, their data types, and whether null values are allowed. So after each column is defined, just press the Enter key to add the next column. Now, when you added all the required columns, just close the Query tab by clicking on the X on top of the Folder tab. And don't worry, you're not going to lose your work. You just have to be careful. Now, notice the pop-up dialog box that appears when you click on the X, and it asks you if you want to save the design. Just click on OK to continue. And now you're going to get another little pop-up dialog box there. Okay, so it's asking you to enter the name. Now, in this case, it's customer. notice all of the columns that we defined for this table, the customer ID and the first and last name plus the full name. And you can just see the country, state, city, postal code, and address table, columns that are hidden there. So obviously it's a customer table, so just click OK, and the table is created. All right, so look what happened. It created the table when you refresh on the table folder, but it went into the default schema DBO. So you now need to change the schema to another schema. And this is easy to do. There's just a few steps. I'll mention them now, and we'll just take a look at them in the next clips. All you need to do is right-click on the table name in the table folder, select Design. Then in the Design pane, right-click again and select Properties. And then in the Schema drop-down list box, just select the desired schema. All right, just click Yes to the warning message. Click the X in the Design Panel tab to close the Design pane. And click Yes to the warning message. And finally, click Yes to accept changes. All right, that's a lot of steps, and I'm sure you probably remember probably none. So let's take a look here. All right, you're in the Design pane. You have all of the columns, right? You just right-clicked on the table and clicked on Design. So now in the Design pane, just pick a spot, a blank spot anywhere, and right-click on it and click on Properties. Once you click on Properties, you're going to get a whole bunch of information. All right, so all you need to do is go to the Schema drop-down list box, scroll down and select the desired schema, and then click Yes to the warning message. Now click the X in the Folder tab to close the query pane, click Yes to the warning message, and click Yes to accept the changes. And that's pretty much all that there is to it. All right, so there it is. Just click again. That's that warning message, and once you get rid of it, your table will be assigned to the new schema. As I mentioned earlier, the second way to create a database tables is to use the DDL command create table. And DDL, just a little reminder, it stands for Data Declaration Language. Now the basic syntax is simple. You just use the create table command. You supply it a optional schema name, then a period, then the table name. Now recall that a schema is like the name of a container, so you can group related tables in this container. So, if you have a schema called, master data, you can probably have table names, that is, you don't have the physical tables, but table names like the customer table, the customer address table, maybe the customer demographic. So it's just a container to group related tables, maybe in a business sense. So then after you supply the create table, the schema name, table name, between the set of parentheses, you just define the columns. So each column, you include the column name, the data type, and then an indicator called null or not null, which means that you can either leave the column empty when you're filling in the rows, or it's mandatory to supply a value. And then you supply, after that last closing parentheses, you supply a file group name. So recall when we created the databases that we have dedicated file groups with data files in them, and that's where the tables were stored. Now here's some grumpy tip alerts. Okay, use nvarchar for storing Unicode data and varchar for ASCII data. And tip number 2, use that dedicated file group. All right, make sure that the table is in a good file group. For example, you might have a file group for master data. But anyway, that's pretty much it. Now in this clip, just take a look. We've got a customer table. We're going to put it in the stage schema. So notice I'm saying use sales data warehouse. So this clip is supposed to mimic a data warehouse database, and we're going to create a staging table for the customer table. And basically, we're creating that file group stage_FG. And then we're listing all of those columns, right? The customer number, it's an identity column. That means that it can be used as a primary key. Now, one thing of interest with the identity column is you don't have to supply values for it. SQL Server will supply incremental values. So in this case, if you're inserting that first row of the customer data, the full name, the first name, the last name, and all that address information, the identity column will be supplied with the number 1. Then once you insert another row, it's going to be incremented and you're going to get a customer number of 2, and so on. So I think you get the idea. So we'll see how to do all this in a demo, by the way. But now we have to talk about loading tables. Okay, we're going to load some data in tables, and you probably guessed by now that there's 2 ways of doing this. So there's loading tables with SSMS, and here's how you do it. Basically, just right-click on the table in question. In this case, the master data.department table. Right-click on the table and select Edit Top 200 Rows. So notice a new folder, a tab folder appears with the, in this case, you see 3 rows are already filled in. But I can go ahead and start filling rows for department D003, D004. So after you fill in each row, just hit the Enter key until you're finished. And then all you need to do is click on that good old little X again, and all your changes will be saved. So we're going to see how to do this in our demo. But it's pretty simple. But one word of caution, make sure you understand your data, that you just don't start adding data willy-nilly, without worrying about actual primary keys, like if the department IDs are valid, or if the manager ID actually exists. Like the manager ID should come from an employee table. We have all your employees, right? So a couple of them or maybe more are managers. So again, just make sure you understand the data. Let's now see how we can populate the tables that we discussed. Well, we discussed the department table, I believe. But let's look at how to load tables with TSQL. Okay, there's a DML, a data manipulation language command that we can use called insert into. So the syntax, again, is fairly straightforward. There's the keywords insert into, then you supply a schema name, an optional schema name, and a table name. Now, what do I mean by optional? Well, you might only have one table created in the default schema DBO, in which case you don't have to supply a schema name. But what if you have a table by the name of course in the DBO schema, and then for some reason you have another course table in the HR schema, and so on? Then in that case you do have to supply a schema name so that you identify which table you really want to load. So anyway, so insert into schema name, table name, then the keyword values, and then between each set of parentheses, you include all the data for the columns. Now, if all of the columns are labeled as not null, so as in the case here of the course table, you see it's got 2 columns. There's course ID, which is not null, and there's course name, which is also not null. And they're both varchar, different lengths. So notice the rows that we're inserting. The first row between the parentheses is C001 for the course ID, and then marketing basics for the course name. And notice that text data is surrounded by single quotes. Now, if you have situations where you have like integer or numerical columns in a table, you don't have to supply the quotes, right? If they're either integers or money or decimal or floating point. And then with the department table, as you can see, we're inserting those 4 rows, department D01 through 4, human resource department, payroll, marketing, and inventory, and we're supplying a manager name for each. So as can be seen, the syntax is fairly straightforward, and that's pretty much all that there's to it, all right? So here's what we're going to do. Let's do our first demo. We'll create some tables using both methods, and we'll insert some data into the tables using both methods. And by that I mean using SSMS Object Explorer and also TSQL. Okay, here we are in SQL Server Management Studio, and we're going to start creating some tables. We're going to be using my instance Grumpy 2019 I2, instance 2. And we're not going to recreate the human resources database. We do have it there already, as can be seen. But here's the code to drop the database if it exists, and also the code to recreate the database. So let's just check out the properties of this database before we start adding tables. Okay, so for files, we have, let's see, we have the primary data file, human resources, then a single data file, human resources data, and a human resources log file. And it looks like we have a file group called human resources data. And sure enough, there it is. Okay, and it's also the default file group. So what that means is that if we create a table and we don't specify a file group, it'll go there. All right, let's scroll down nice and easy here. Let's see what we need to do. All right, we also have a customer database that we'll be using. Okay, so we have, let's see, any tables in here? Just 2 tables. All right, those were created with SSMS, so we'll probably have to drop them. But that database is there. All right, so there we go, create table with SSMS. And there's our specification for the table. Now we do have those tables there already. So what I'm going to do is I am going to delete them first with SSMS. This is a topic for later on in this podcast. But let's right click on customer, click on delete, and there goes customer, and let's click on customer demographic. Let's delete that also. All right, so let's start creating new tables with SSMS. All right, so let's right click on the tables folder and click on new table. Now we do need that specification, so I'm going to click on that tab where the spec is. I'm going to select new vertical tab. So now we can see the specifications. All right, so our first table to create with SSMS is customer. So we have 3 columns in here. The logical names are customer identifier, customer last name, and customer first name. So let's see if I can cut and paste this and cheat a little bit. I'm going to put that name there. Insert column. Will it let me paste it? No, it won't. Oh, well. All right. CUST_ID. And our data type is nvarchar 32. So there's an nvarchar. We just need to click on that length. And let's see, is it not null? Allow nulls? No, we want this to be null. Then we're going to create the customer last name column. CUST last name, and that's also a nchar. And actually I made a mistake here. It's an nvarchar. I'm being a little too quick here. Where's nvarchar? Nvarchar 50. Let's make it nvarchar 32. And we're also going to make this nvarchar 32. Okay. Now we are going to allow nulls. And then finally, customer first name, CUST first name, same thing, nvarchar 32. Okay, nvarchar 32, and we're going to allow nulls. Okay, let's click on the little X to close this tab down. And do we want to save changes to the following items? Yes, we do. And here comes our little dialog box. So we want to call this table customer. Very good. So we click on OK. And let's refresh our tables folder. And there's our customer table. All right, but it's in the wrong schema. But we're going to address, let's see that, add that a little bit later. Yes, we are. We already have a master data schema. So I'm going to create the customer demographics table the same way. And I'm going to fast forward because we've already seen basically how to go in and put in all these columns. I'll just get us going. New table. All right, there's our little tool to start defining the table. Move this to the right. So let me fill the customer demographics table there. And we'll fast forward and we'll be right back. And here we are. Everything is filled in. 3 columns: customer underscore ID, cust underscore credit rating, small integer, and custom marital status. There's an N of varchar 50. So let's click on the X, and we want to save it, and we're going to call this table customer demographics. Should actually be a customer demographic. Good relational theory doesn't allow you basically, or it tells you not to use plural names like customer demographics. So we'll just call this customer demographic. Click on OK. Little mid-course correction here. Let me get rid of this S. All right. I'll save my changes. Let's refresh our tables folder. So there we have the 2 tables. Now what we need to do is to basically move these out of the DBO schema to the master data schema. We don't want production tables to go into the default schema DBO. So we'll right click on customer and select design. We get the design pane. Right click on the design pane and click on properties. Go up here to schema and scroll down to master data. Okay, changing the schema of this object will result in all current permissions on this object being dropped. Are you sure you want to proceed? Yes, that's a good idea. All right, so we've made that change. Let's get rid of this little design pane. It's going to ask us to save changes to the following items. We'll say yes. So now if we refresh the tables folder, so we see the customer table is in the master data schema. So I'll quickly do this for the customer demographics. There's design. Don't even have to right click on properties this time because there they are right there, little properties window. Let's go down to master data. Say yes. So we want to basically change the schema. And close the design pane, click yes again. Let's refresh tables. There they are, master data customer demographics. Let's get rid of the properties pane here and just expand this. So now we need to load a few rows in each table. So let's start off by doing the first customer. So we're going to populate these tables. I've cheated a little bit here. I already have a customer table in another database on the other instance of SQL Server. So I'm going to populate the table with these values here. Let me go back to the correct instance. Here we are. And I'm going to right click on master data customer. And I'm going to edit top 200 rows. And as you can see, I get an empty little pane here. And what I need to do is, again, put this in a new vertical tab group so I can see the data. So I am just going to add those 5 rows. I'll do one here to show you how to do it. And then I'm going to fast forward and do the other ones. Now, so I'm going to add customer 001, CUST underscore 0001, and the customer name. Okay, so I tricked myself. That's not actually correct because this is for a Acme plumbing supply, and I should be putting in some names of people. So I'm going to back out of this. I'm just going to make them up on the fly. C001. I'm going to call this person John Smith. I think that's a good generic name. And I'm going to fast forward and add 5 customers in total. Okay, so I've added 5 fictitious customers. I'm just going to close this down. And let's do we'll get rid of this pane. We don't need it. So let's just right click on this master data customer table, select top 1000 rows, and there they are. Okay, let me just go and put this in the new vertical tab. So I can now fill in the master data customer demographic table. Okay, so it's going to be pretty much the same exercise. I'm going to right click on it, edit top 200 rows, just expand this a little bit. Now I definitely need to be careful because I want to use the correct primary key, which is customer ID. So I need to add 5 rows for customer demographics, specifically the credit rating of each customer and the marital status. So I'll do the first one, C001. Oh, customer credit rating, let's give this person a 10 out of 10. And the marital status will say M for married. And I'm going to fast forward and do the rest. Okay, there's all the 5 rows. We've inserted them with the SQL Server Management Studio. Let's just get rid of this data entry pane. Hopefully we were successful. Let's select the top 1000 rows. So sure enough, we have the each of the 5 customers. Everything looks well. Customer C001, customer credit rating of 10, marital status M for married. Same for C002, little lower, customer credit rating 8, marital status married, and so on and so forth, right? Just some fictitious customers, fictitious data. So let's get rid of this little query pane and this one. So let's see what's next on the agenda. So now we are going to create some data, some tables rather, with TSQL, all right? So we're going to collapse the customer data. Let's refresh the tables folder here. We have no tables. So let's create a schema called HR for Human Resources. Now what we'll do is we'll drop the schema first with the drop schema if exists command, just in case it exists. I almost violated my own rules. Make sure we're in the correct database. All right, we're in the Human Resources database. Very good. Let's drop that schema if it exists, and then create the schema HR. All right, just start off with a clean slate. So we'll create a department table. There it is, create table HR.department. Department or DEPT underscore ID varchar 16, the data type, and we're declaring it as a primary key and not null. We need to specify departments. Then DEPT underscore name for department name, varchar 256, also not null, and MGR underscore ID varchar 16, not null. And we're going to create this on the Human Resources file group, so pretty straightforward. So here's one way of declaring a primary key, as I said. So let's execute it. Let's refresh our tables folder. Very good, there it is in the correct schema. Let's create an employee table. Now this is going to be a little bit more complicated. We're going to start off with the create table HR.employee command. all right? And the employee EMP underscore ID, employee ID, is going to be the primary key. It's a varchar 16 not null. Then we're going to add a whole bunch of other columns, all not null. All right, there's going to be the DEPT underscore ID for department ID, varchar 16. And then I'll just call them out. The employee first name, last name, and long name are varchar 256, all not null. And the manager ID is varchar 16 not null. Now, the hire date are going to be null, all right? I didn't specify the null or not null indicators, but if you leave them out, by default, their nulls are allowed. So hire date and end date. Now, here comes something a little bit, we'll call it maybe complicated. We're going to add a link back to the department table relationship. And this is called a constraint. And the way you create a constraint in the create table command is by using the keyword constraint, then you give it a name, in this case FK underscore DEPT, foreign key department, right, real imaginative name. Then we're going to declare it as a foreign key, and it's going to reference the DEPT underscore ID column. And which column is that? Well, below there we see references HR.department DEPT underscore ID. So the department ID column in the employee table will reference the department table, specifically the department ID column. And then we have two more commands on delete cascade and on update cascade. So what does that mean? Well, that means that if we delete a row from that parent table, the department table, then it's going to automatically delete all employee rows that have the deleted department ID. Now, on update cascade, what that means is if we go in there and update a department ID in the department table, it'll update all employee rows in the employee table with the new modified department ID. And again, we'll put it in the human resources data file group. Let's execute this command, refresh. Okay, there's the tables right there. If we right click on one and look at the properties, all right, we'll see the general information, the name of the table, the date created, other important information. But for our beginning podcast here, we really just care about the name, the schema. There's the schema HR. Let's see anything else. Storage. Let's see what storage tells us. Okay. And there it is. It's in file group human resources data, and there's really no data space taken up right now. So there it is. We've created a couple of tables with relationships. Let's see if that constraint showed up. Let's refresh it. No constraint showed up, but it should have showed up as an index. So there it is. So the index implies that relationship to the department table. Okay. So let's scroll down. I'm going to create a salary table. We'll drop the schema payroll if it exists. Then we'll create the schema payroll. Right, just a little house cleaning, start off on a clean slate. Okay, pretty much the same thing. This time we're going to create a table salary in the payroll schema. We'll start off with the employee ID column there, EMP underscore ID, varchar 16. Right, let's take a look at the columns here. Yes, varchar 16 in the employee ID in the employee table is correct. I'm just checking the data type and the length. A salary of decimal 10, 2, which is not null, but notice the default operator there. It's if we don't enter any information, the salary will default to 0.0. The from date is going to be not null. All right, so a salary record needs to have a from date, and the to date null. All right. And here is a different way of defining a primary key. We're going to add a constraint called PK underscore EMP underscore salary. There's the keywords primary key. And this time we have two columns for the primary key. the EMP underscore ID column, and the from date, right? Because we're going to have multiple salary records for each employee. So as employees get promotions and hopefully their salaries go up, we have a trail of all the salary history. And then we have a little with ignore dup key command equals off. So that means that if we enter a duplicate key, we're going to get an error. And here's how we define that foreign key constraint, all right, FK underscore salary underscore employee. So the FK implies, right, foreign key. This table is the salary table, and it's going to reference EMP, basically the employee. So we want our name to mean something. The foreign key is based on the column EMP underscore ID in the salary table, and it'll reference the HR.employee table via the EMP underscore ID column. So pretty straightforward once you understand it. And again, on delete cascade, on update cascade, and human resources file group. All right, so let's just highlight this little guy here, and let's create the salary. Let's refresh our tables folder. So there's our salary table. So that's the end of topic 2. So what do we want to do basically? Well, we want to populate the tables. All right, so we're still in the human resources database, so we don't have to execute that use human resources command. We just created the tables, so we really don't have to delete the rows or truncate the table. And we're going to use the insert into command. We're going to insert into HR department these values D001, human resources, and then the employee E001. All right. Now let's insert these departments. Notice that each row is delimited by a parentheses, then a comma. Then you have the next row, D002 payroll, employee 005, and so on and so forth. Let's just look at these columns. Specifically, we're going to supply department ID, department name, and the manager ID. Okay, so let's insert those rows. 4 rows are affected. Let's just check them to make sure. There they are, 4 rows affected. So now let's do the same with employee. All right, so we want to, let's expand on this employee table first. All right, we want to insert the employee ID, the department, then the employee first name and last name, the long name, which is basically just the first name and the last name concatenated, the manager ID, all right, and then the hire date and end date. So notice the end dates are all null. Now, in the case of the first employee, E001, the manager is also E001. So I guess this is the CEO of the company, right? He reports to no one, or she reports to no one. Well, it's John Smith, so it's a he. Then there's, let's see, a row for Mary Smith and Susan Smith and a whole bunch of other people, right? So I basically just made up all of these names. So let's just insert all of these rows. It's a good way of doing it if you don't have too many rows. In this case, looks like we have 16 rows. So let's check out. Well, actually, here we're going to insert, that's right, we're going to insert one more employee, E0099, belonging to D099 department. We don't have one of those. So we're going to see what happens in queries when we're looking for employees that are assigned to a department that doesn't exist. But there's that insert into HR employee, the values operand, values with an S, a single set of parentheses, and all the data. There's got to be data in there that corresponds to each of the columns, unless we have a little interface there that just calls out which columns we want to insert into. So let's execute that insert. So let's see, the insert statement conflicted with the foreign key constraint FK department. That's right. That's what happens when you try to insert a row and no department exists. So what do we need to do for now? Well, we either need to insert a new department D009, or we're going to have to assign John Smith to another department. So that's what happens. That's how constraints work. All right, so let's try department D004. This time it worked. Let's look at all of our employees. Okay, so now we've got 17 employees. Very good. Now we want to do something a little bit tricky for inserting data into the salary table. We basically want to generate artificial salary records. And the way we're going to do this with a series of select statements that are unioned. Okay, there's that union all operand, which connects the results of the first select statement with the results of the second one, and so on and so forth. What I'm going to do is I'm just going to cut and paste, or copy and paste, I should say, the first select into a new query window. Okay, I'm going to paste it, scoot it over here to a new vertical tab. So let's take a look at it. This query is typical for all of the queries that are in the select statement. Okay, I'm giving a salary record for all of the 16 employees. I'm excluding employee E0017, but I could basically add him if I wanted to. So basically I'm selecting the employee ID from the HR employee table, but then I'm using two functions, one called RAND, which is the random generation function. It'll generate a random value between 0 and 1. I'm going to multiply it by 100,000. Then I'm going to round it off using the round function to 2 decimal places. I'm going to call it employee salary. And then I'm going to also include the hire date from the employee table, the null, and then I am going to filter it with a where clause where employee ID equals E001. So let's execute it. So there it is, a little random value, a small salary, $10,256.28. So probably our CEO here is only there a part of the time, or he's got a token base salary, but he probably gets a compensation with bonuses in the hundreds of thousands. Again, all fictitious employees. Let me copy and paste all of these commands now, so we can see how, by using the union all and the random function to generate some example salary records, we can populate this salary table with at least 16 rows. So let's just paste them here and execute it. So there you see we've now got 16 records of employee salary data, and some of the salaries are pretty small. If we execute it again, let's execute that button, we're going to get a whole different set of values, all right? And one more time, still good values except for employee 10, $4,553.70. So anyway, let's go ahead and insert them into the salary table. So notice it's all these select statements and then insert into the salary table. There they go. 16 rows affected. Okay, let's copy and paste this select statement here. Let's get rid of this query so we can look at some employee salaries that don't look too good. All right, all of these look fairly good except for E007, which is low, 13,737. And E0012, which is only $2,391.47. So let's give E0012 a raise. Maybe this was an intern. So we're going to set the to date to, let's see, October 1st, 2020. And the employee ID we want to change is 12. Okay, so we want to set the to date to 10/001. That's good. And the from date is going to equal to 20. We want to filter it rather, where the from date, employee 12, is this little guy here. I can copy it by clicking on it and then just pasting it here. Okay, so now let's update this employee. So what did we just do? Let's re-execute the query there. So employee 12 now has a to date that's basically terminates that period of temp worker status. And we're going to now insert a new record for this employee, because now that person has been hired. That person was an intern. So now we're going to give this person, let's give them not that much. Let's lower this down to $75,000. That's a good entry-level salary. And the start date is October 2nd, 2020. Let's insert a new record. Let's see what we got. So now for employee 12, if you'll notice, we have two records. Now if that's not too clear, okay, let's query it this way by filtering it. And there you see employee E012 with the two records. So that's how that works. That's how you insert and then update records. All right, so that's it. We need to go back to our clip and learn about dropping tables. So we've gone through a fairly lengthy demo. We've created two databases, created, I think it was 3 tables, and populated them. So guess what we're going to do now? Now we're going to learn how to delete those tables. And we're going to learn how to delete those tables with SMS and also with TSQL. So with SMS, here's how you do it, all right? You just right-click on the table in question in the tables folder, all right, and click on delete. And by the way, some grumpy wisdom. Okay, once it's gone, it's gone. So what appears is a nice panel. So just check everything out just to make sure that this is the table you want to delete it. Okay, make double sure, because sometimes, like me, you might click too fast and you pick the wrong table, and then you're in trouble if you just delete it without checking. So once you delete it, it's gone. So make sure you back up the DDL code used to create the table, and make sure you have a backup of the data, all right? Like in a spreadsheet or some sort of archive table or a text file stored in a secure folder. And now here's some more grumpy wisdoms. Mistakes can and will happen. All right, let's see how to drop a table with a TSQL. Okay, and there's a couple of comments. Now, what if old scripts are using the old names, that of the tables you're about to delete, all right? So you might want to check for dependencies before you drop something, all right? And also you might want to make a backup. So in our script here, I'm about to drop a table called Master Data Department Backup. Okay, this is a table I definitely know I want to drop, because it's a scratch table that I use to make backups. And I can recreate it on the fly with a special type of select query. I can type the word select star, then I include into masterdata.department_BU. So that's the table that was just dropped. So this is going to recreate that table on the fly. And then I'm going to retrieve data from masterdata.department. So now I want to check for dependencies, right? I'm going to run a store procedure called sp_depends. I'm going to pass it the name of the table that I want to delete, in this case masterdata.department. And the report will show me all other objects that reference this table. We're going to see it in our demo. And then what you do is you drop the table, if exists, masterdata.department. And then if you don't need that schema, all right, you drop the schema too. All right, so these commands are real simple, and the ones that drop the table in the schema are dangerous. So make sure that what you want to drop is what you want to drop. All right, so let's go and do a demo on dropping tables. Okay, now that we've created a bunch of tables and populated them, it's time to drop them. So let's start by dropping tables with SSMS. All right, let's drop table payroll salary. That's the last one, if you recall, in the constraint chain, right? They're all linked together. The parent table of employee is department, and the parent table of salary is employee. But before we drop this salary table, let's just quickly back it up with a little trick there. The select star into payroll.salary_backup, BU for backup. It'll create that table on the fly from the payroll salary table. So let's just back this up. Right, we should have all those rows backed up. And let's refresh our tables folder. There it is. There's our backup table just in case. So let's just delete the payroll salary table. Right click on it. Let's see, delete. Scroll down to delete. There it is. You get one last chance to review everything. And while we're at it, let's take a look at dependencies, show dependencies. So let's see, objects that depend on salary, none. How about objects on which salary depends on? Ah, yes, the employee table, which depends on the department table. So a good little tool to use for checking dependencies. All right, we're going to just delete this table, no problem. All right, let's now drop tables with TSQL. We're actually going to sneak creating a view just so we can show how dependencies work. Let's take a look. Do we have any views here? We don't, but we could drop them if they existed. We're going to create a view called payroll.salary_view. Now recall when I say payroll dot, that's the schema that the view and or table will go to. So creating a view is simple in this case. Just use the create view command. Supply schema name. It's always good to have a period. Then the view name, in this case salary_view. I like to end view names with the word view so it's real clear. Then the keyword as. Then the query that I would like to base this view on. Well, guess what? I deleted that salary table. So let me just make this as an _BU just to show you how that SP_depends function works. So when you select these columns, right, we get all the columns to show you the the data that's in that backup table. So we can actually rename this view. Let's call this a backup view. Actually not here, we'll put it here, BU_view, BU_view. So we got a view here against the backup data. So let's just create this view. And let's take a look at if there's any dependencies. So SP depends payroll.salary. Well, we don't have that table, right? So let's call it _BU. Are there any dependencies? No, there aren't. All right, so there's the name and the view. How about the dependencies of the salary view, the salary BU underscore view. Any dependencies there? Oh, yes. So salary underscore BU depends on a user table, and there's all the columns: employee ID, salary, from date, and to date. That's the actual table itself. So this view depends on this table and those columns. But in this case, there's no danger. We already deleted the salary table. So let's go ahead and drop the other tables. Now there's two ways of doing it. There's the traditional drop table command: drop table payroll.salary, drop table payroll.employee, and drop table HR.department. Now watch what happens if I try to drop the salary table, which we already dropped. We're going to get an error. So this alternate format here is the way to go, because if the table doesn't exist, it's just going to say, man, no problem. All right, so there's two tables that we need to employ, and we need to, delete, and we need to do it according to that dependency chain. So since employee depends on department, we need to drop this first. All right, well, let's see what happens. Drop table if exists department. Let's try to drop this table first. Okay, we're going to get an error. You can't drop object HR.department because it is referenced by a foreign key constraint. Makes sense. So let's drop the table employee. And that should work fine because there's no dependencies left. All right, and now let's drop the table department. And they're all gone. Let's refresh all these tables. Okay, well, we have the salary backup. All right, so they're gone. Let's just drop the HR schema, drop the payroll schema. Cannot drop schema payroll because it is being referenced by object salary BU. Okay, so even dropping the schema is protected. Let's right click on that salary BU table. Let's delete that. That's gone. Now let's drop the payroll schema. Okay, the view, see? Let's refresh the view. We can also drop views in SSMS by right-clicking on them, just like tables, deleting them. All right, now, third time's the charm. Can we drop this payroll schema? All right, let's try it. Okay, great. Now we have an empty database, and we're where we started from at the beginning. So that ends this demo. Okay, did you get all these guys? In this podcast, we looked at how to create tables. We saw how to load them. And I had table constraints, primary key to foreign key, and drop tables. Now recall that we did this in two ways, one with SSMS and the other with TSQL code. And we also learned how to check for table dependencies with a stored procedure called SP_depends. Okay, so that's it. So let's just wrap things up by taking a look at my tool podcasts and also the other podcasts that are in this series. Well, I hope you enjoyed this podcast, and I hope you learned the basics of creating and dropping tables. Now here's a list of my podcasts for the category of SQL Server tools. There's 7 podcasts. Now podcast T01, Installing SQL Server 2019. This shows you how to download and install SQL Server 2019, and it's probably the most important of the tools podcasts because you need SQL Server before you can do any of these exercises. Then there's podcast T02, that's the next most important. That's installing SQL Server Management Studio 2019. And that's what we've been using now in these podcasts is SSMS. Then podcast T03 is installing Data Tools 2019, and it'll install it into Visual Studio. All right, it'll give Visual Studio the ability, to manage and create, or I should say create and manage SQL Server-based projects. Now, if you don't have Visual Studio 2019 Community, well, podcast T04 is for you. It shows you how to download and install Visual Studio. Then podcast T05 is installing reporting services. So this is a very important component of the BI stack, the SQL Server BI stack. And it's a full web-based architecture where you can create and upload reports based on SQL Server data. And also other data too, right? You can use the data from spreadsheets and text files and other vendor databases. As long as there's an ODBC driver, well, you can create a reporting services report with the data from the data source that has that driver. Podcast T06 is installing Report Builder. So this is a nice little graphical tool that'll allow you to create web-based reports that you can publish to reporting services. And finally, Podcast T07 is installing Power BI. Now this is a very advanced and powerful, I'll call it an analytical and statistical tool, which will really round off the whole BI experience with using SQL Server. So I really suggest you look at all these podcasts. Okay, one more clip to go. We're going to look at all the podcasts in this series. Okay, here's my list of available introductory T-SQL podcasts. All right, there's podcast 01, Navigating SSMS, in case you didn't take a look at that. And this is the first podcast of my podcast that you've checked out. So I definitely recommend you go and look at Navigating SSMS. Then podcast 02, Creating Databases. And then podcast 03, Creating Tables. That's this podcast. And then podcast 04, Creating Views. And we had a sneak peek of creating views in this podcast so that we could see how the SP depends stored procedure works. Then there's podcast 05, T-SQL DML. Recall T-SQL stands for Transact SQL. And DML stands for Data Manipulation Language. So this podcast is really important and interesting. You'll learn how to write sophisticated queries that use joins and where clauses. And you'll also learn how to insert more data, update data, and delete data. Then podcasts 6 and 7 show you how to use Microsoft SQL Server's built-in string and date functions in your queries. And podcast 08 shows you how to use the order by clause. Now the order by clause is used to sort the data results once you execute a query. And finally, podcast 09, the group by clause, shows you how to set up groups when the data is returned. Well, what do I mean by groups? So for example, if I want to see sales by calendar date, customer, and product, that's a grouping, right? So when you define these groups, you can use other built-in functions like sum and minimum and maximum. And we're going to see how to use those functions, by the way, in the T-SQL DML podcast. Okay, so those are my podcasts. I hope you find them interesting. And then here's a little shameless advertising on my part. Please be on the lookout this fall for my Grumpy University at grumpyolditguy.com for a complete buffet of T-SQL courses to enhance your skills. Okay, see you in my next podcast, podcast 04, Creating Views.